All right, so in the next question, what we're going to do is take this average rate of change we're doing, and instead of doing it from a specific interval, starting somewhere and ending up at 4, we're going to say, let's go from 4 minus delta t to 4. So what does that interval look like? Well, if here's 4 on the t-axis, and if I go over delta t to the left, then my t-coordinate is going to be 4 minus delta t, because I went delta t to the left. So that's what it means that we're going to do this interval 4 minus delta t. That way, instead of looking at a bunch of specific intervals, I can handle really all the intervals at once by not specifying what the delta t is. So, for example, here the delta t was 2, here the delta t is 1, here the delta t is 0.5, here the delta t is 0.1. So I can handle all those at once. All right, so, but I use the same expression to do the average rate of change, which is t of b minus t of a over b minus a. So that means I'm going to go t of 4 minus t of 4 minus delta t over 4 minus delta t, right? So don't lose track of the fact that it's always t of b minus t of a over b minus a, which is the same as y2 minus y1 over x2 minus x1, the slope formula. You can see it right here, y2 minus y1 over x2 minus x1. Okay, so now we got to take our t function and use our t that we have up here. So we're going to say that is equal to, oh, well, t of 4 is 37 plus 3.1 times 4 squared, and then minus my t of 4 minus delta t. So I have to plug 4 minus delta t in for the t there, which means I'm going to need parentheses, and I'm going to need a big parentheses around the whole thing because I'm going to be subtracting something with a plus or minus in it. So then I have here 37 plus 3.1 times 4 minus delta t squared. All right, so that's my numerator. Now in the denominator, 4 minus 4 cancels out, and I just have positive delta t. So my denominator is just delta t. Okay, let's maybe carry that to a separate paper now. So I have this expression. So this is number 2. So now I can say, let's see, I can combine all. Well, let's see what happens. I guess I could do all this. I can also sort of think ahead to how this is going to be 37 plus 3.1 times 4 squared. I'm just lazy. I don't want to do 3.1 minus 4 squared. So even though this is probably going to cost me more writing, if I just distribute the minus, so I have minus 37 minus 3.1, right? And then if I square out the binomial here, I'm going to have 4 minus 2 delta t plus delta t squared. Right, so that's my numerator. Hopefully I haven't lost anything. I got my distributed that. Yeah, that looks good. All right, my denominator is delta t. So the reason that I like that, actually the 4, I lied. It's 4 squared. So that should be 4 squared, which is 16. So you could have 16 there, and this should be 8. Okay, so is that all the mistakes I've made? So if I do 4 minus delta t squared, I'm going to get 16 minus 8 delta t plus delta t squared. So there you go. There's that expression. Okay, now continuing on with that. So the reason that I did like that is I can see that the 37s can cancel, and I can also see that 3.1 times 4 squared is going to cancel. That way, I don't even have to work out what that is on my calculator. Okay, so now all I have left is distributing the negative 3.1 times negative 8. Well, I can do that in my head. It's 24.8, right? So I have 24.8 delta t. And then just the negative distributes, remember, so I have minus 3.1 delta t squared, and then the denominator I have delta t. All right, so that's what I have for my expression here, is I can say this equals 24.8 delta t minus 3.1, is that right, 3.1? Yeah, 3.1 delta t squared over delta t. All right. Oh, I wondered why I had so little space here. I was supposed to do all that stuff down here. So actually this stuff goes down here. This is actually number 3. Number 3. This stuff goes here. Okay, factor delta t out of the top and reduce. All right, so looking at this expression, I can factor delta t out of the top. So I have delta t times 24.8 minus 3.1 delta t. and in the denominator I still have delta t. That's factor out delta t, and then reduce. That equals 24.8 minus 3.1 delta t. All right, what is the crucial difference? So the crucial difference is that delta t cannot equal 0 in the unreduced expression. That's the critical difference, the crucial difference. Okay, let's see what we have next. Then we have, oh, okay. So then we have this chart. So we'll pop the chart up to another video.